This is the video solution to practice problem A that accompanies sample problem 2.7 on page 57 of your text. This question asks us to write the empirical formulas for 3 different compounds. We're given the molecular formula for each compound and a ball and stick model of each molecule. We're probably going to get more information from the molecular formulas. Let's run a quick comparison before we look at the molecules involved. We've already seen that a molecular formula tells us the actual number of atoms of each type that are found in a molecule of any compound. And again, that's the information that we have here in the problem. An empirical formula tells us the smallest ratio of atoms that make up a molecule of the compound. It's important to note that sometimes the molecular and empirical formulas will be the same for a given compound, like water, for instance. The formula H2O is the molecular formula. We believe that water molecules are composed of 2 hydrogen atoms and 1 oxygen atom. If we take a closer look at this formula, we see a ratio of 2 hydrogens to 1 oxygen. That ratio can't be simplified to any lower whole numbers, so the formula H2O is also an empirical formula. The easiest way to look at things here then is to see if all of the subscripts in a molecular formula can be reduced by some common multiple. If you can do that reduction, what remains is an empirical formula. If you can't do the reduction, the formula itself is already empirical. Letter A asks us to consider caffeine, the legal stimulant that's found in a wide variety of beverages. Our molecular formula for caffeine is C8H10N4O2. All of the subscript values in this formula are even, which means that to write an empirical formula, we'll need to divide all of these values by 2. And our empirical formula will end up being C4H5N2O. Let's just check to be sure that this is empirical. We have one element, the oxygen, with a subscript of 1, so we cannot reduce the formula any further. Letter B is butane, C4H10. In this formula, we also see that the subscripts are even values. We will divide all of the values again by 2 and arrive at an empirical formula of C2H5 for butane. Let's just check this. We have a subscript of 2 and 5. Those 2 values cannot be reduced by a common multiple. Letter C is the compound glycine, an amino acid. In this compound, we see that we have subscripts of 2, 5, 1, and 2. The fact that the nitrogen's subscript is already as low as we can make it, it's already 1, means that we won't be able to do any division here. And our empirical formula for glycine is the same as the molecular formula, or C2H5NO2. Please take a moment to look at practice problem B in this group of exercises. You can check your answer with the key on page 75 of your textbook.